Let g be a function with first derivative given by g prime of x equals the integral from 0 to x of e raised to the negative t squared with respect to t. Which of the following must be true on the interval x is greater than 0, less than 2? So from these answer choices, we can see that we need to determine whether the function is increasing or decreasing, and concave up or concave down. So to determine whether the function is increasing or decreasing, we have to look at the first derivative of g of x. And they gave us the first derivative g of x. It's this integral here from 0 to x of e to the negative t squared dt. So just by looking at this integral, we can determine that this integral is always going to be positive, because inside here is this e raised to the negative t squared, and we know this is always going to be greater than 0, because an exponential function with base e raised to some power, no matter what value we plug in for t, this result will always be positive, whether it's 0 or some negative number. So, and since this function in the integral is always positive, then that means when we take the integral of it, we're always going to get some positive area. So that means that no matter what value we plug in for x, as long as we keep going to the right, the area under the curve that we're measuring using this integral will only either stay the same or keep increasing. There's no way for the area to go down because this function is always positive. Remember that the integral finds the area under the curve, and that area is positive if it's above the x-axis, and it's only negative when it's below the x-axis. So the only way for this function, the integral to go down, would be if there was negative area. But since this function is always positive, we know that g prime of x is always greater than 0. And since g prime of x is always greater than 0, that means that g of x is increasing. Remember that when the first derivative is greater than 0, your function is increasing, and if the first derivative is less than 0, then it's decreasing. Okay, but now that we know that it's increasing, let's find g double prime of x, or the second derivative of g of x, because the second derivative tells us about the concavity of the function. So g double prime of x is going to be the derivative with respect to x of g prime of x, this integral, e to the negative t squared d of t. So here we're taking the derivative of an integral, and the second fundamental theorem of calculus states that when you take a derivative of an integral, it's just equal to the integrand in the integral, but with the upper boundary, the upper limit, plugged into the integrand. So we're going to plug in x into t. So we're going to have e to the x squared. So this is our value of g double prime of x. And similar to what we saw up here, we know that this is also always positive. This is another exponential function raised to some power. No matter what we plug in for the power, this function will always be positive. Like, obviously, if we plug in a positive number, we're going to have a negative exponent. And we know that a negative exponent just means you take it down to the denominator. So this is just equal to 1 over e to the x squared. And since e to the x squared is always positive, we're always going to have some positive number. And since the second derivative is greater than 0, that means g of x is concave up. So now we know that our function is increasing and that it is concave up, which means A is the correct answer.